All right, so today we are going to finish up protein synthesis with translation, okay? So we've already learned that DNA to RNA is transcription, and today we're going to talk about RNA to a protein, which is translation. So it's the second part of protein synthesis. So we've already seen this when we talked about DNA and RNA, but the order or sequence of bases in an mRNA molecule determine the order in which the amino acids are joined together. And we're going to see this as we go through the presentation. Okay? So there is what is known as the genetic code. The genetic code is the language of mRNA instructions. So each three-letter word is called a codon, and that is what we are going to use to find a particular amino acid. So in mRNA, we have what are known as codons, okay? tRNA is what carries the anticodon, and we're going to talk about this as we go on. So mRNA carries the codon, and that is our most important piece because that's what we are going to use a codon chart for in order to determine amino acids, okay? So if you are given this sequence, right, and you had to convert it, you would essentially have to take this, which is what? Is this DNA or RNA? How do you know it's DNA? There's no U's, there's T's. So this has to be DNA. So what we would have to do is we would have to transcribe this to RNA first in order to find the amino acids. Because when you see the codon chart that's coming up, the codon chart is mRNA. So you cannot use DNA to find an amino acid because on the codon chart, you're only going to see A, U, C, and G. Okay? A, U, C, G. So this codes for leucine, which is an amino acid, and we're going to talk about how we find this piece. Okay? So translation essentially decodes the mRNA that we made from DNA to produce a polypeptide chain. And we've talked about these before. These are when I compared a pearl necklace at the beginning when we talked about macromolecules weeks ago, okay? Those polypeptide chains are our protein. And it is going to happen at the ribosome. So mRNA takes DNA's message from the nucleus into the cytoplasm and heads to the ribosome. So we did talk about three types of RNA, okay? M, T, and R. mRNA is the messenger because that's taking DNA's message from the nucleus. rRNA is this big green piece in the middle. That is ribosomal RNA, which essentially just makes up the ribosome. And then the last piece is tRNA, which stands for transfer. That's what carries the anticodon and brings in the amino acid. So that's this bubble T up here, okay? So the codons on mRNA, your single strand here, is going to bond to the anticodon that tRNA brings in, okay? So this happens in a series of steps. So the first one, mRNA attaches to the ribosome. So this single strand here is your mRNA. That came from DNA's message in the nucleus. Then we're shifting colors here. This pinky brown color, however y'all see it, this is the ribosome. So this is where mRNA goes to. And the ribosome is in the cytoplasm, okay? So the second step, each tRNA, so these bubble-looking T's, they carry an amino acid to the complementary sequence on the mRNA. So that is the anticodon matching up to the codon. We don't need to be so much worried about this as we do with this and the amino acid that it brings in, okay? So we're worried about the codon on mRNA and the amino acid that tRNA brings in. Everybody with me so far? Okay. Step 3. The ribosome forms bonds between the amino acid in order to start building that polypeptide chain, which is essentially our protein, okay? And then last, the tRNA will float away. So typically, okay, if we were to get into greater detail about this process, there are 3 sites, the EPA, okay? So there's the acceptor site that accepts the tRNA. Then it goes to the P, which is the peptidal site, where the amino acids start linking together, as you see here. And then there is the E site, which is the exit site, and that is where tRNA would leave, okay? So accept, start building our peptide bonds, linking our amino acids together, and then leaving, okay? So up here you see a picture of a codon chart. Now, the one that you see, this is like a cheat chart. So I don't want you to get too familiar with this one. I would rather you use the one that I linked in your module and your announcement from today. And I will also print them out for you so you can have a paper copy, because this is something that's a little bit easier to do on paper, okay? So the way that we're gonna do this is there's the first base, the second base that goes across the top, and the third base down the right-hand side, okay? So this is where we really need to pay attention, because I need for you to understand this. You are going to have to answer questions based on this chart. So the way that I like to teach this is that your first base is always a row. Your second base is always a column, and your third base is an individual line. So everybody follow me, row, column, line. So what you have to do, if you are given, for example, the codon AUG, which we would find on mRNA, you would go to the A row, okay, the U column. So if we have to be in the A row and the U column, the best way to do this is to use the finger trick. So you have to make them meet, because you have to be in the row of A and the column of U. Everybody with me so far? So it's like a group. Yes. Okay, everybody with me? So if I have to be in row A, column U, I cannot leave this box. Okay, I have to be in this box. So now your third base, which in this case is G, is the fourth line of that box. So you would look in the box you're stuck in and look to the fourth line, and that would give you your amino acid, which in this case is MET or methionine, which is known as the start codon. Okay, everybody with me? So we're going to do some practice on this to make sure that we all understand what we're doing. But just to go through it, everybody follow. So row, column, line, individual line. Okay, so let's do GAG, gag. Okay, so I got to go where? G what? Row, G row, okay? Okay, so do I go here?
No, you go to the very bottom.
Why?
Because that's where the G and the A meet.
Okay, that's where they meet, all right.
The bottom one, that's where the G is.
So glutamic acid. Everybody follow so far?
Yeah.
Pretty easy? All right, we're gonna do some.
To write these and draw these? Okay, good.
Okay, you're gonna have to figure out the amino acid if you are given a sequence of codons, okay? I'll explain as we go, okay?
So it's like, if you think about it, so you always start on the left and then you move right.
Correct.
It's pretty much like a clock. So, because you know how a clock's a circle,
Yep.
and you start at the bottom, the top, and you go around like that. So it's like starting on the 9 o'clock and then having to go to the 12 and the 3.
You can look at it that way, absolutely. That works for you. I like it. Okay. All right. So for example, we're going to do UCC. So we've got U, C, right? Everybody with me? And C. So what's the answer?
I can't see it there.
Serine. So it's S-E-R. Okay. All right, let's do AGA.
Yeah.
Arginine. A-R-G. Okay. Everybody got the hang so far? All right. Next, we've got UGU. Cysteine. So C-Y-S. No, you're good. Cysteine. All right. And last is UGA. Beautiful. Stop. Okay. So if you ever see the start codon, which is methionine, or the stop codon, that is what tells you the start of a specific protein. So that amino acid is starting that protein sequence, okay, of amino acids. And then the stop codon is what signifies the process to stop, okay? Start, stop, exactly what it says it is. All right, so let's try this. So we've got DNA. We have to transcribe it first because we need mRNA to find the amino acid, okay? So T is gonna go to what? Okay, so it's gonna look like this. Then you need, for a codon, a sequence of 3 letters. So every 3 letters, you can circle or put a line between so that you know what you're looking for your amino acids. Okay, so those are our codons. We have 3. So now we have to find the amino acids using the codon chart.
What is the codon chart?
I'm gonna give you one that doesn't look quite like the one that you saw. It looks very similar, just doesn't have the letters in the front. You'll see. Just
Wait, but are they always the same letters?
yes, yes. Okay. So AAU, you would have to use your codon chart to find, and it would be ASP. GCA is ALA, alanine, and UAG, which is stop. Okay.